Hello and welcome to the SSC Community Discussion Hour. My name is Annalisa Ventola. I'm the Chief Editor of Edge Science, and I will be your host for this event. I have with me Professor Nalin Chandra Wickramasinghe, who is a world-renowned astronomer, astrophysicist, and pioneer of astrobiology. In 1977, together with the late Sir Fred Hoyle, he proposed the theory of cometary panspermia, the theory that comets carry the seeds of life and that life is distributed throughout the universe. Discoveries in geology and astronomy continued to provide evidence supporting his theory known as cometary panspermia. From 1963 to 1973, he was a former fellow of the Jesus College, Cambridge, and a founding member of the Institute of Astronomy in Cambridge. From 1973 to 2010, he was professor at Cardiff University. He has published over 450 peer-reviewed papers in scientific journals and over 30 books. The professor's talk is pre-recorded. However, he is here, as you can see, and he is going to be joining us at the end for live Q&A. We will now begin the presentation.
Discuss today an age-old conflict between two rival ideas, rival theories about how we, that is to say life, came to be in the universe. And I would like to cite this as just one example of a situation where culture, religion, and tradition apparently trumps all facts relating to the problems that we have at hand. Take, for instance, the case of the Roman numerals. I mean, this is maybe a little bit of distraction, but I think it is relevant. If you look at these Roman numerals, they are hideous. I mean, they are 1, 1, 1, 1, 1, 1, 1, I, V, I, and so on. And these are numbers that were in vogue throughout the European state system until about the 18th century. And it is really remarkable that one could just imagine doing long division and calculus, etc., with these Roman numerals. And there were mathematicians in the 17th, 18th centuries who really protested against the use of the Roman numerals. And but as I said, they were used throughout Europe sort of unabashedly from about 1000 AD, or 1000 Common Era, to about 800 AD, even though the number system that you and I are all accustomed now, which is called the Hindu Arabic number system, was actually brought to the notice of European practitioners, European scientists. But they rejected the idea because it was connected with a deep-rooted suspicion of non-Christian, non-European origins of this system. So this is the reason why it was not readily accepted by philosophers, mathematicians, accountants, and so on in Europe until the 18th century. This is an interesting story. In the 7th century AD, of the Common Era, an Arab scholar called Severus Sebokht brought this to everybody's notice, and he wrote to his friends and colleagues and so on everywhere in the so-called civilized world. He wrote the following: I will omit all discussion of the science of the Hindus, the people not the same as the Syrians. Their subtle discoveries in the science of astronomy, discoveries that are more ingenious than those of the Greeks and the Babylonians. Their valuable methods of calculation, their computing that surpasses description. I wish only to say that this computation is done by means of 9 signs. If those who believe, because they speak Greek, that they have reached the limits of science, should know these things, they would be convinced that there are also others who know something. And the others who know something, of course, knew something much better, the number system that we are all familiar with, 1, 2, 3, 4, and so on. has come to be the cornerstone of all our cultural development since the Enlightenment. Anyway, but Europe, as I said, did not adopt this Hindu-Arabic number system until well into the 18th century. So that's the background. So I would really like, in a more general sense, to bust the myth that scientific truths are always secure and inviolable and independent of cultural constraints. That's what we are led to believe when we are taught science in our schools. In the modern technological age that we live in, of course, such a belief is understandable. Take our cell phones, our computers, and so on. These are just marvelous things, and we all enjoy the marvels of scientific achievement that prevail in the year 2022. But the greater and deeper truths about the world we live in are far from secure. And this includes, of course, the origins of life in the cosmos, the origins of consciousness, which I think you have discussed in your journal on many occasions, and the origin of the universe itself. But I should add at this point a caveat that portions of the scientific canon, the orthodox science that we believe or we think is really definite and are secure, there are several of these, and they include Newtonian dynamics, nuclear physics, for example, anatomy, and a lot of others, but are based firmly on the empirical method. Our recent triumphs, for instance, in classical mechanics, which is a secure science from the 16th century onwards, is really shown almost day by day with the various achievements that we are making. For instance, this September, a few weeks ago, in fact, the DART mission sent a probe, sent an object, essentially, a large object, to hit an asteroid over 7 million kilometers from Earth. And the success of this mission to send this object all the way to the moon of the asteroid called Dimorphos was really a great feat of scientific achievement. So there are many things like that that are based on areas of science that are secure, like Newtonian mechanics. And then there is, for instance, nuclear physics, which is a definite science that tells us how the sun shines and how the stars shine, how we all get our energy from the sun. And these are hard facts, and they're beyond refutation. In the case of the sun, for instance, for protons linked together at the very high pressures that exist in the deep interior of the sun, they link together in the nuclear reaction that produces helium, releases a neutrino, positron, and of course the energy that we enjoy, the solar energy that we depend upon. And all life on Earth depends on the radiation, the light from the sun. But similar certainty does not apply for ideas or theories about the origin of life and the origin of the universe. These are matters, as I said earlier, that are inextricably linked to culture and religion, and are still, unfortunately, rigidly controlled by the force of authority in the modern world. And the force of authority means institutions, universities, teaching systems, and perhaps most importantly, the academies, like the Royal Society, the French Academy of Science, and so on. And these started in the early stages of the European Enlightenment. Theories about the origin of life, how life began, of course, has a very deep history that goes back several millennia. The basic choice that we have, as we shall see, is between two propositions. One, the idea of spontaneous generation. That's called the theory of spontaneous generation, which says that life started from non-life spontaneously. And the competing theory that I have been working on and subscribing to for over 4 decades is the theory of panspermia, which says that life is a cosmic phenomenon, eternally present in the cosmos and taking root whenever and wherever the conditions for life become suitable. As I said, so this goes back a long time, and the idea of panspermia dates back, in the Western tradition at any rate, to a Greek pre-Socratic philosopher called Anaxagoras. Anaxagoras proposed that life appears spontaneously from non-life whenever the conditions, the ambient conditions, are satisfied. So this is, as I said, in the Western tradition goes back to pre-Socratic times, but in the older traditions of, for instance, in ancient India, the Vedas, it goes back even further to about 2000 BCE, and that's in the Vedas, for example. The idea of spontaneous generation, that life starts spontaneously whenever conditions are appropriate, for example, on this planet, this is a much later idea that came into Western traditions, Western philosophy, about 150 years after the inventor, the European inventor, a Greek inventor of Panspermia and Anaxagoras. It was due, so spontaneous generation was assigned firmly to a philosopher, perhaps a greater philosopher in the history of science and history of philosophy, and his name is Aristotle, who lived in the 3rd century BCE. He was a pupil of Plato, the great philosopher Plato. He was a teacher of Alexander the Great, who was, of course, he was a towering influence on Western philosophy. It was he who introduced the Earth-centered cosmology, also the idea that the Earth is the center of our solar system, and also spontaneous generation, which implies Earth-centered biology. So these ideas of Aristotle in the Western world were to dominate Western thinking for over 2,000 years. But this is important to stress at this point, that it was greatly assisted, the dominance of these ideas, this Earth-centered solar system, the Earth-centered life system, and so on, was greatly assisted by the rise of Christianity, Christendom. It was this guy, St. Thomas Aquinas, who in the 13th century provided institutional support for almost the whole of Aristotelian philosophy. He adopted every bit of Aristotelian philosophy into Christian theology, and so that was the starting point of a very rigid belief in Aristotle's ideas of this role of the Earth in the universe, and the role of life being centered on the planet Earth. And most important questions then thereafter, concerning our existence and so on, became inextricably linked with theology and culture. So that's the story. And I think we all know that the attempt to dismantle Aristotle started in the beginning of the 15th century of the Common Era, began with Copernicus, and Galileo and Copernicus challenged the idea that the Earth was at the center of the solar system, center of the universe. And this, of course, was taken very, very seriously by the church establishment, by the papal establishment, and there were many casualties. Galileo was imprisoned. That was not a great punishment, but Bruno, the philosopher, poet, mathematician, lost his life in the process. He was burnt at the stake in 1600. Sorry. So this is Giordano Bruno, a philosopher, mathematician, poet, burnt to death for saying that there were other inhabited planets with life on them orbiting other stars. And there on the right-hand side is a statue of Giordano Bruno with myself in Italy. The long debate about whether life started on the Earth or was brought from outside. So the debate between spontaneous generation, the intellectual debate between spontaneous generation and panspermia began to take a very serious turn in 1865 when the French biologist Louis Pasteur made a groundbreaking discovery. And I think in that discovery, he decisively disproved the idea of spontaneous generation. So he had this system where he had a broth, a nutrient broth, a broth that microbes like to grow in, and he had he then boiled the broth in a flask with a hooked neck that you can see on top there, and this was the neck that prevented bacteria from the air falling into the broth. And when the broth was sterilized, which means that all the bugs in the broth were killed, and and it remained with this hooked neck lid on the top, there was no microbes to be found under the microscope. When the curved neck was broken, and therefore the broth, the sterile broth was exposed to the air, then microbes grew. And so microbes grew only when viable microbes, when pre-existing microbes were able to find their way into the broth. And this, I think, was the first experiment that paved the way to prove panspermia in the laboratory. And Pasteur, Louis Pasteur, had this dictum, omne vivum e vivo, in Latin, which says that all life comes from life. And that was a doctrine that really ripped through the intellectual scene in Europe for about 2 or 3 decades before it also was abandoned. The conflict, so as I said, the conflict between these two ideas, panspermia versus spontaneous generation, has lasted from essentially until the present day. Every scientific establishment has found a reason to say that panspermia is not established. We don't like it. We prefer the Aristotelian theory of spontaneous generation, life just emerging ex nihilo from nothing when conditions on a planet becomes appropriate. So it was really a conflict that was portrayed as between superstition being panspermia, and science being the idea that that life just springs from non-life. When I myself personally revisited panspermia in 1980, it had already been assigned to the category of superstition. So that's a bad start to begin with. So Aristotle's primordial soup at that time, and right from the beginning of the 20th century, took this form, which is a soup of mixture of organic chemicals thrown into an early primitive Earth, undergoing a set of chemical reactions, ending up with the first microbial cell from which everything else sprang. This was taken further by the work of the 1950s by the famous geologist Harold Urey and chemist Stanley Miller, who in the laboratory was able to show that simple organic chemicals like amino acids and some carbohydrates and so on could be formed in the laboratory. They took simple inorganic chemicals like methane, water, methane, ammonia, put them into a flask, and he showed that these could be formed. But these are very simple biochemicals, very simple components of biology, but it's the very far cry from life. Amino acids and nucleotides are nothing. They are the components, the building blocks of life, but they're a far cry from life. The important aspect of life is the way that these molecules are arranged in different systems, for instance, in DNA, in the enzymes and the proteins that are made via the DNA. And these cannot be assembled by random processes except against a huge probability hurdle. The probability that given all the right simple building blocks, amino acids, nucleotides, and so on, the probability that life would emerge just spontaneously is like giving a two unbiased die, like these six-faced dice that you throw in Ludo and in the kids' board games, and give it to 500 people, and they simultaneously throw double six. Then that's a really incredible improbability, totally impossible. The total number of atoms in the entire observable universe is only 10 to the 80. So the probability of 1 in 10 to the 1,000 is just hopeless, and I think it is bizarre that science still pursues this proposition. So I think it is not surprising that many laboratories in the world, many really quite sophisticated laboratories, have for nearly half a century, been doing experiments to try to prove that spontaneous generation might take place. And all such experiments have been a dismal failure. The two guys who put the modern version of Panspermia, the modern version of the Anaxyrhus Panspermia, into the mix was, we called it cometary Panspermia, and I'll tell you why in a minute. This involves the synthesis, the coming together of well-established sciences, geology, astronomy, and biology. That was Fred Hoyle from 1915 to 2001, and me starting this venture on the right-hand side from 1981. Let's start with geology. What is the evidence we have? The most recent evidence from geology that spontaneous generation is wrong and panspermia is the right answer. It is in 2015 when the very first evidence of microbial life on the Earth was discovered to be locked away in crystals of a mineral called zirconium. These minerals condensed on the Earth from materials on the Earth 4.2 billion years ago, very close to the time that the Earth itself formed as a planet. And these are exposed now, these little blobs of microbes inside the crystals of zirconium, which I point to with those arrows. They're included in the crystal zirconium that is exposed in a outcrop in Western Australia. That's one of the most recent discoveries, pushing back the antiquity of life to the very first moment that life could survive, because we know that this time, 4.2 billion years ago, was a dreadful time in the Earth's history. Dreadful because it was the most inhospitable situation for anything like life to emerge. It was hit by comets, ferociously, comets and asteroids. It was just a fiery furnace. And to find that the rocks that formed at this time carry little bits of microbes is just uncanny. The theory of cometary panspermia is what we proposed over several decades now, and it has many predictions. It is a science. We make predictions. We look for verification of those predictions in astronomy, geology, and biology, and they have been found, unquestionably found over the past 4 decades. So we have primordial microbes, bacteria and viruses that are just in the universe and as part and parcel of the cosmos. They are incorporated in planets that form around stars, and the planets and the comets that are responsible for amplifying, for increasing these numbers of bacteria, throw them back into space. And there's a positive feedback loop where an initial cosmic legacy of microbes is continuously amplified inside the warm liquid interiors of comets. So this prediction, we make a very firm prediction on the basis of this theory that interstellar dust, the dust that you see between the stars in the Milky Way in vast quantity, I mean, all of the dark striations and patches that you see in the night sky on a dark night is made of trillions and trillions of interstellar dust particles. And we predict that these dust particles should reveal the signs of bacteria and viruses in various states of decay. And that's what we began to find from 1981 onwards. This is the first prediction that was verified. The curve is a prediction of the spectral signature of interstellar dust if it were bacteria. If the cosmic dust, the dark material in space, was largely bacteria and viruses, this was what we would expect, the curve. The signature of a spectroscopic signature from 2.9 micrometers to 4 micrometers. And the points are the observations of a source of radiation in this deep universe, in fact, very close to the center of our galaxy, that was discovered in 1981. And when we put these two together, they sat so precisely one on top of the other that we just essentially cheered and said, this is it. We have proved that bacteria are the main component of bacteria, and their degradation products are the main components of cosmic dust. So the theory that we then developed thereafter with comets, these comets are the distributors, incubators, distributors of life in the cosmos. Recent scientific astronomical discoveries have shown that cometary material that are related or derived from comets, like asteroids, bits of asteroids and so on, have all the signatures of primitive primordial oceans within them. And it is within these oceans, within these warm liquid interiors, heated by radioactive heat sources, that microbes in the universe essentially survive and are distributed. And this picture is of Comet Hale-Bopp in 1997. The first evidence that comets really contain living particles also came very closely followed just a few years after we made the prediction that comets should carry microorganisms. There was the first exploration of a comet in the space age, and that was Comet Halley in 1986, made its first perihelion passage after over 80 years. And there were missions, European space missions and so on, to essentially photograph the nucleus of a comet that had not been seen until that time. So on the left-hand side, the orangey picture, the dark patch there, is the comet, which was surprisingly found to be very dark. Astronomers didn't expect it to be dark. They thought it was an icy, like a snowfield, and they were really shocked and surprised to find that it was so dark. And then we had the spectrum of the comet taken by my brother, in fact, in Australia, and David Allen. And again, the points in the curve on the right that match the curve is a correspondence between the spectrum of the dust that flowed out from Comet Halley in 1986 and the prediction of a bacterium. So there were two hits that essentially came within a couple of years of each other, proving in our minds that this is the right idea for the existence of life in the universe. Well, ever since then, ever since the 1980s, comets have been the focus of astronomical investigation. The most recent mission to a comet was, of course, the Rosetta mission, which ended in 2016. And in that mission, complex organic molecules that were relevant to life were discovered in great quantity, and an exceedingly dark surface was also found, similar to the situation we found in Comet Halley in 1986. So this is the Rosetta mission comet 67P CG. And it also led to a detection of the surface reflectivity of the comet's material of the comet. How does the comet reflect infrared light? And again, these curves, I don't want to go into details, but the curves show how closely the observed reflection spectrum and the infrared matched the properties of a bacterium. I think I should maybe, this is to do with culture and so on, so I should make a mention of this. I, along with my colleague in Cardiff, Max Wallis, was on part of the science planning team for the Rosetta mission before it was launched. And we suggested that they put on the landing device, which is called Philair, the lander that landed in 2014 on the surface of this comet. We suggested that they put a simple life detection system where you pour a nutrient onto the soil and see whether the nutrient is taken up. Of course, cultural constraints were strongly operative at the time, and these prevented the inclusion of a simple $10,000 experiment, which may have proved once and for all that the comets are sort of full of living particles. Anyway, that's the way that science proceeds. And recently, or no, not before Rosetta, in fact, there were several instances where the living comet idea was essentially proved by astronomical observations. We had a comet, and I've already showed the picture of this comet here, Bob, in 1981, when it was way past the orbit of Jupiter in the cold depths of space. It was essentially exploding, popping, just sort of exploding and producing huge comas, tails, reflecting material around. And that really baffled scientists because at 6 astronomical units or a distance of beyond the orbit of Jupiter, the comet was so cold that it could not have there could not have been any evaporation of material from this surface. So what was happening was that biology was taking place underneath the surface of the comet. There was high pressure pockets developed and just sort of popping off like a fermenting broth, and that was repeated again. This is the story of a famous London brewery and a classic incident in 1814, showing that fermenting beer could explode and produce a huge flood of material. And that's exactly what happened in the case of the comets. In September 2021, this last year, a giant comet, a very large comet called Bernstein, was at even a greater distance than the Hale-Bopp comet was when it was near the orbit of Jupiter. It was at 2 billion kilometers from the sun and acted in a very similar way. It exploded, it became very luminous and should not have been luminous at that point when the surface temperature was minus 210 degrees Celsius. It flared up on one day on the 19th of September. This is still a great mystery for guys who don't like to think that comets have biology exploding within their interiors. But this was explosion that was detected only a year or two ago. Then I think this is interesting. This last month, there was as I referred to already, the DART mission of the mission to deflect a comet or an asteroid if it was heading towards the Earth. So this led to the collision between the this is Dimorphos, the moon of this asteroid, and the DART mission hit this spot on, and the whole thing that exploded. So it'll be left to be seen whether these filaments that are coming out essentially contains, again, the spectra of living material. Whether that would ever be done for cultural reasons remains to be seen. So the question then that I want to pose is, are microbes, viruses from comets coming to the Earth today? And I would like to maintain that this question can be answered decisively and precisely, and we can get a definite answer tomorrow, but culture and prejudice and even religion perhaps stands in the way. To step back a little bit, I mean, in the 1980s, when we first expanded and wrote about the idea of comets bringing life, and we regarded comets as being an integral part of the evolution of life, biological evolution being directed from space, viruses coming from comets, causing pandemics like influenza, and in more recent times, the coronavirus pandemic, and also the idea that viruses are responsible or plays an important part in the entire evolution of life from its first inception in those bacteria that you saw 4.2 billion years ago to the present time. So, and to answer the question whether comets have been connected with evolution, I should mention that the crucial step that was involved in this whole process of connecting comets, viruses in space, and evolution was the unraveling of the human genome in the year 2000. We now know that the human genome, our DNA, contains over 5% of sequences that are actually derived from viruses and that interacted genetically with our ancestors, with the ancestors that led to us eventually, ancestors also of all the plants and animals. And in case of humans, I think there's also growing evidence that these viruses that were responsible for evolution was also responsible for bringing genes that permitted speech, consciousness even, and brain function. And this is ongoing research. So the evolution of hominids, for instance, over 1 million years is marked, we think, by successive pandemics from space, like the coronavirus pandemic recently. And each of these pandemics turned out to be a very close call to total extinction. But we survived through this sequence, and we essentially emerged in the present time as Homo sapiens. So viruses, as I said, have contributed to the evolution of our brain, even to the evolution of consciousness. In relation to the evolution of consciousness, it's interesting that the human brain doubled in size, in volume, just 500,000 years ago. And what caused it? We don't know. I think it could be of viruses that were brought from outside. Well, I think having said all this, the important question is, how could we prove that this is happening even at the present time? We know that the Earth, this is a picture of all the cometary orbits, the short period comets, and the red circle here is the orbit of the Earth. The Sun is at the center. The Earth's orbit then is clearly in the midst of all the debris that sort of thrown out from the comets. And so these comets, the Earth is picking up this debris on a regular basis. So could it be verified? Could we collect this cometary debris gently before it became mixed up with the Earth's muck, Earth's bacteria, and so on, and examine it? And we tried to do this in the run up to the new millennium. we didn't have any luck from European, American, British space agencies. But the Indian Space Agency, called ISRO, Indian Space Research Organization, came to the rescue, and they, this very sophisticated organization, the Indians have been great scientists in the past and also now. So they decided that they would go for this, and they sent very, very sophisticated collection devices. These are the collection devices that was lofted by balloon, by the balloon here, shown here, to a height of 41 kilometers in the atmosphere, in the stratosphere, on the 20th of January 2001. And what they did was essentially these cylinders were evacuated to begin with. This is a vacuum. The vacuum was open here, the valve was open, and when it was in the stratosphere, all the stuff that was around was sucked into the cylinders, and the cylinders were brought back, parachuted back to ground, examined in the laboratory. So this was a very, very important experiment that was done in 2001, led to a large number of scientific papers that are in the literature and are being just marginalized or ignored. We found evidence of bacilli, of nanobacteria, of viruses, and the height of and these structures that are fluorescent because they are living, and the height of 41 kilometers we reckoned was too high for lofting microbes from the Earth. I mean, there are processes that take microbes from the Earth to the high atmosphere, but to 41 kilometers you don't get very much, except perhaps in times of volcanoes, and there was no volcano at the time. The estimated daily input of microbes over the whole Earth on the basis of this experiment that we did, we can do a sampling experiment. We can take a little volume of the stratosphere, see how much stuff has been injected in one day, and it leads that calculation leads to 0.3 to 3 tons of microbial matter coming in from space every single day. Now, that is a tremendous amount of bacteria, and it's mind-boggling to think that has not been investigated with all the techniques that we have today, all the biological techniques, all the experimental techniques. From the evidence from what we did in 2001 and the known speed at which these things fall, we know how fast particles can drift through the air. We can estimate that something like 0.3 to 3 tons, as I said, of bacterial viral material falls through the sky or stratosphere every single day. And that translates to 20 to 200 million bacteria per square meter, every square meter of the ground, per day. And this flux of bacteria would normally go unnoticed because there's a huge amount of sort of local bacteria on the Earth, as we know. The Earth is full of bacteria from all sources. But it's an amount, the 20 to 200 million bacteria per square meter a day from space, is an amount that we cannot afford to ignore. And yet, science has ignored it to the present time. 3 years ago, or 4 years ago, a team of European American scientists, Rich is the principal investigator, have recently shown that above 2 to 3 kilometers, there's a downward flux of viruses that could be in excess of 7 billion per square centimeter. Now I said per square meter, now it's per square centimeter per day, and viruses in excess of 70 billion per square meter a day. So that's a lot of viruses, and undoubtedly, anything falling from the height of 2 or 3 kilometers would include stuff that is pulled up from the surface. But it also includes the material that is coming from much higher up, as I said, the 0.3 to 3 tons that are coming from space. So it's all mixed up. And it is, again, mind-boggling that no attempt has been made to separate the stuff coming from space from the stuff that is on the Earth. So that's the bottom line, is that technologies are available, but they're available only in few, not many laboratories in the world, to essentially to separate the space bacteria, space incident bacteria, from the indigenous bacteria on the Earth. So there's, as far as the skeptic is concerned, as far as the guy who wants to believe in spontaneous generation is concerned, there is a convenient uncertainty that prevails in regard to the origin of these entities. Finally, let's come to the question of whether there was ever a beginning of the universe. This is connected because if life was ever present in the universe, when did it start? Was there a beginning of the universe? Was there a beginning of life in the universe? The current, culturally, of course, the situation is that there was a Big Bang, which is essentially a scientific rendering of the Judeo-Christian story of creation. Big Bang, 13.8 billion years ago, and there's a huge catalogue of events that have been charted, some supported by observations, astronomical observations, some through pure speculation. So 13.8 billion years ago is the current preferred date for the origin of the Big Bang universe. But the James Webb telescope that began to function only a few months ago is already threatening this picture very seriously. This is an object called CERS 93316, presumed to be the most distant galaxy, and it is now at what is called a redshift. It's moving away from Earth at a redshift of 16.7, implying that it's at a distance of 35 billion light years from the Earth. That should not be there. At that point in the history of the so-called Big Bang idea, there should be no galaxy, there should be no atoms even. So what is this new galaxy doing here? And I think there are going to be more and more of these things found. How the astronomical establishment, the cosmological establishment copes with these new discoveries is still left to be seen. Ideas relating to the antiquity of the universe has a very long history and a very long non-European history. For instance, in the Vedic Hindu philosophies, an infinite sequence of creation and destruction is posited, and these are essentially ancient Vedic Indian ideas. According to Carl Sagan has written this about, 20 years ago, the Hindu religion, we referred to Hindu religion earlier at the beginning of my talk in connection with the number system, the Hindu-Arabic number system, but this is now in relation to cosmology. So Carl Sagan says, the Hindu religion is not only one of the world's great faiths dedicated to the idea that the cosmos itself undergoes an immense, indeed an infinite number of deaths and rebirths, it is the only religion in which timescales correspond to those of modern scientific cosmology. Its cycles run from our ordinary day and night to the day and night of Brahma, 8.64 billion years long, longer than the age of the Earth or the Sun, and about half the time since the Big Bang took place, if there was ever a Big Bang, that is. And there are much longer time scales still. So the current models that are being discussed in the astronomical literature is one by Roger Penrose, Nobel laureate Roger Penrose, and his students, where there is a sort of sequence of expansions and contractions, and the ideas of Fred Hoyle, Burbage, and Janet Nalika, where there was some kind of similar system to what Penrose has revived in more recent times. So maybe there was never a beginning. Maybe life was always present in the universe. And the creation cycle of Hindu cosmology is just a poetic expression of an eternal universe, which is oscillating in an endless series of creation and rebirths. So the alarming tendency into 2020 is to ignore this entire body of evidence that supports not only panspermia, but an infinite age of cosmology, infinite age to the universe. The idea that viruses, microorganisms, bacteria are continually arriving from space, despite all the evidence that we have accumulated, all the very powerful evidence, this is being essentially marginalized and regarded as not admissible, inadmissible evidence. So this vast body of new data is disregarded as being controversial, culturally inadmissible, belonging essentially to a non-standard, perhaps a non-European knowledge tradition. This attitude, I maintain, poses an imminent danger, not just for science, but for the well-being of humanity as a whole. Perhaps the worst casualty of all, once we admit that we are not unique in the universe, that life is cosmic and so on, will be our self-image as a supreme life form in the cosmos, which will, of course, be shattered and require major efforts in psychological readjustment. When this paradigm shift is fully conceded, and I hope it is going to be conceded, it is likely that the entire structure of human society will undergo a transformation more fundamental, more profound than any that has taken place so far. In 2022, the culturally accepted Big Bang bandwagon and the origin of life on Earth bandwagon is close to falling over the edge. Would we have the courage to admit it? Thank you very much.
Hello. Okay, and we are back. So thank you so much for your excellent talk. I want
It went on too long, but and my voice was a bit hoarse, but I think it came across okay.
No, I was thinking, I'm going to let the audience know that earlier today I had the option to edit this down, and I saw the entire lecture and I wouldn't have changed a thing. So
Okay.
we get to watch it in its entirety. So I just want to remind those of us here at AirMeet, these are SSC members and patrons, please put your questions in the designated Q&A. And if you are camera ready, you may also use the raised hand feature to ask your question directly, but do keep in mind that this event is being recorded and live streamed. So, okay, we have a question actually from the SSE president, and I'm going to go ahead and show this on stage. She says, this is from Margaret Moga. Can you discuss advanced panspermia, the possibility that intelligent life on Earth is a result of a purposeful experiment carried out by an extraterrestrial civilization?
Well, I mean, that is a real and stark possibility that is being completely ignored in discussions of life in the universe, life on the Earth. I think if panspermia is the answer to how life originated and how life evolved over millions or billions of years, then the idea that there is a purposeful experiment also being carried out by a very advanced, super advanced, intelligent civilization that can actually inject material to the Earth, carrying messages coded in for instance, in viral genes, and attempting to alter the process of human evolution. This has to be taken very seriously, but it's totally abandoned in the annals of respectable science. It's relegated to the realms of sort of science fiction, and and maybe superstition. So this is another instance where we have to keep all options open. If life did not start here on the Earth, the possibility of more advanced life than ours, than humans existing widely in the universe, really has to be taken seriously. And this has really not been even remotely considered as an intelligent way of looking at things. For example, I mean, if we project our own human civilization, human technology, say for another 50 years, it would be entirely possible that humans would be able to devise, engineer a life form that is far superior, perhaps, to life that exists on the Earth, human life, for example, make a huge number of viruses that code for this information and just throw it out into space. And so what would happen thereafter is that if there is a nearby planet with life, with civilization, for example, like ours, they would be essentially impregnated or infected with this new information input, and so there could be a deliberate attempt made by an alien civilization more advanced than ours to influence the progress of life on our planet. I think it cannot be ruled out. It's maybe it is still a way out idea, and so I respect the conservatism that prevails, but I think if panspermia is admitted, all bets are off. We have to admit these possibilities, at least consider them for what they're worth.
Thank you for your answer. Now we have a raised hand from Beatrice Villarreal, who incidentally is also the chair of an upcoming symposia that we are hosting on astronomical anomalies. So I invite Beatrice to ask her question directly.
Hello. I have a comment and a question. So I just wanted first to say how actually important your papers were for me for my personal journey to become an astronomer. I was an undergraduate student I was studying molecular biotechnology. And I remember one day I was taking a course in microbiology, and we were asked to present some essays on how we thought that the life came to Earth. And I was very inspired by your ideas on panspermia, and I wanted to present this for the class, and I was not permitted. I was the only one who was not permitted because it was such, so different from what the biology teacher wanted. And after that, actually, that was the final step before I switched to astronomy. I later did a PhD in astronomy, working with quasars. Actually, very much like our ideas also on the quasars, and which I didn't follow later, but it helped me very much for my journey as a scientist. And today I'm also involved in SETI, such as for extraterrestrial technology. And I wanted just to ask you, so that was my just comment on that. It has been very important for me to these ideas of panspermia for my professional career. And I actually wanted to ask you if you would pick your favorite 2 methods to search for life outside the Earth, how would you do it? What would you bet on?
Well, I think I would do 2 things. One is to look for evidence of exoplanets with living signatures, and that is a possibility that is really very close to being realized. We have, for example, the James Webb Telescope, Hubble Telescope just until recently, and so on. So spectroscopy, very detailed spectroscopy of any detected exoplanet might reveal signs of biochemistry. But in terms of, showing that life exists, or that panspermia was the reason for life existing on the Earth, this has also to be resolved decisively, because the data is there, as I pointed out. There are tons of material, biological material, falling on the Earth every single minute, and they're just being swamped by the native biology. There's so much biology, so much bacteria on the Earth. But it is really, really very important, I think, that we use our available biological techniques and experimental techniques to try to separate the infalling component from the indigenous component, and to see how these two components, first of all, to show that an alien component does exist, right? And we can do that, for example, by studying the isotope signatures of the bacteria that are coming in. For instance, if the alien bacteria came from a source where the carbon isotope ratio was different from the Earth, we could perhaps detect the difference here on the Earth. Just a minute, there's a phone humming here. Yeah, so that's one way of discriminating between the infalling bacteria and indigenous bacteria that should be done as urgently as possible. And so that's the second. First is to look for biosignatures in exoplanets, and then to study in as detailed a way as possible that component of living material that is definitely extraterrestrial, and there is evidence that such material does exist. So it's a travesty of science. It's an insult to our collective intelligence that this is not being done, and in your personal case, that people didn't even want to hear your assessment of the panspermia story. I mean, that's censorship at a very deep level.
Well, I'm thankful for that it happened, because it brought me to astronomy, and it brought me to where I am today. So in the end, I'm quite happy for all these events.
Yeah,
I'm enjoying my science where I am today.
well, yeah, astronomy is a really exciting discipline, and it's getting more exciting with all the new developments in new astronomical telescopes, the space telescopes, the exploration of asteroids, and so on. It's accelerating at such a pace that sooner or later it will not be possible to deny the fact that there is life outside there.
I think the same.
Thank you for joining us, Beatrice. We're going to go just a little bit past the hour. And we've got, I'm going to say 2 more questions, sort of. One is I had a question of my own, and I see other people are thinking similar things. You were talking earlier about the, what was my notes? The initial cosmic legacy that is responsible for this panspermia. And then we also have Jean Thomas, who had a comment that even if life was later spread throughout the universe, it nonetheless had to have a beginning or many beginnings that did not rely on seeding from other sources. Thus, cosmic life is a combination of a spontaneous generation and panspermia. And then also Stephen Hall says, even if panspermia is the way life began on Earth, you would still need to account for the origin elsewhere, right?
Yeah.
So how do you respond to these ideas?
Well, I think he's right. I mean, we could really got to find an answer to if it ever started. If it was eternally present, then we don't need to worry about any start of life or any start of anything. But if it did start in a location that is much bigger than the Earth, right? For instance, if the space that is needed for spontaneous generation is essentially a whole galaxy or a cluster of galaxies, how did it start there? How did it overcome the improbability odds against life that I've mentioned? I mean, Hoyle and I had, I think, a metaphor that is probably has been immortalized to say that we think that the origin of life is like saying that a tornado blowing through a junkyard with all the bits and pieces, the plastics and the screws and so on, assembled a fully working Boeing 747. I mean, we've gone a long way from Boeing 747s now, but anyway, that's the kind of improbability that one has to cope with. So it has to start somewhere. If there was ever a beginning, right? And this is the question that is a deep philosophical question that depends on your personal point of view, right? The Babylonians would say there was no beginning. The Indians would say there was no beginning. But the Western tradition favors the beginning, I think, for reasons that are connected with theology. After all, I mean, God created the universe, God created the earth, God created life. So there was in the Western canon, in the canon of, I should stress that I'm not bashing any religion. I think Christianity is a great religion. It's been a civilizing force for centuries and so on. But it has an underlying philosophy that is not supported by science, which is the story of origins. Okay, did that answer?
Yeah, I think it does. Yeah. Thank you so much. So we have a few more questions. Unfortunately, we're running out of time. But I will say that we're going to ask one more. But before we close with the last question, Chandra has agreed to join us in the social lounge. So some of you will have opportunities maybe to ask directly once we are done with the session. So the final question comes from the SSE secretary. He asks, at the end of your talk, you said that if panspermia is accepted, it would have major changes on humanity. Can you elaborate on that, and what makes you think that this knowledge would change humanity?
Well, I think what would happen immediately is that scientific establishments, universities, and so on would suddenly realize that they've got to teach a different story, right? The story that we are being told constantly for the last 50 years, ever since universities and academies got very powerful, was that there was no other alternative but a beginning of life on the earth, and that sort of gives human beings a very important position in this whole story. Humans are, in some ways, the center of this whole process of life, the culmination of the whole process of life, starting at some point on the earth, perhaps, or maybe elsewhere, but leading up to humanity. If that is eroded, if that is threatened, then I think our sort of view of ourselves is going to change. We are not anything special. We are just the outcome of a process of cosmic evolution, and that's the reason that I think that we would become trivialized, or we would feel trivialized. The other aspect, of course, is that if scientists and if philosophers have held a certain point of view for 100 years or many hundred years, if they are proved to be wrong, then their egos are shattered. They've got to change their point of view, and nobody in a professional situation is very happy about changing their point of view. They become less important. Their self-importance is eroded.
Yeah, that makes sense. Well, SSE members, patrons, I encourage you to stick around. We're going to open the social lounge. Chandra's going to visit us for a little bit. Thank you again, Professor, for joining us. It was a wonderful afternoon, and I look forward to chatting with you some more in the lounge. So I will end the session. Stick around. We will join you shortly.
Okay.